Ooh, wow, it's pretty bright out there. Yeah, whatever. That's fine. Is everyone okay with that? That's good. Um, so if you're on Canvas and you're getting notifications, I did update all your grades on either Thursday or Friday. I don't recall which day it was. Was it Thursday? So I've put in everything I pretty much have for you as far as grades are concerned, and I will pass everything back to you today. So this is like all the quizzes and attendance quizzes and things like that. If you go online and you look at your grades, if you click on the quiz itself, like where it says quiz 1, quiz 2, I believe if you click on it, it'll show you what it was. I think the first few quizzes it doesn't, but like the last few, it'll say like that was a quiz on it was attendance on this date, or it was whatever the assignment was. That's so if you're wondering like I have a 0, why do I have a 0? Oh yeah, I wasn't there that day or something like that. Let's see here. Does anybody have a problem with me just passing this around? I have also, if you turn in bonus, right, if you turn in any bonuses, I've applied those to exams or whatever it needed to be applied to. So when you get the bonus back, it'll say like +5, and then it'll say like EX2, which means +5 on exam 2. So if you have any questions over any of this, just let me know. I'm going to start this. Let's start over here. Just make sure this packet gets around. Make sure you go through the whole packet. Grab what you need. Like I said, we are going to take a quiz today, but we're going to do it at the end of class as opposed to in the beginning. And that's because what I'm going to do today is, remember last time we went through that sheet, that handout that I gave you that had all the steps for factoring trinomials? I said that that's the way the department had agreed that we wanted to do this, right? Today I'm going to show you a slightly different approach, the one that I normally teach if I had my own free will to do it that way, right? So let me do that by starting what our next section is, which is factoring trinomials still. But remember last time we were looking at a very special case. Let me bring up the last class. The last class I started, where was it? Yes, but it was, these are the things that we were trying to factor. Remember this? All these steps that we had to go through, step 1, 2, 3, 4, all this thing, making that table. Remember all this? And the big condition that we had is when we were factoring last class, this thing in the top right, that's our trinomial. The big condition we had last time was that the number in front of the x squared had to be 1 in order for this to work, right? Today we're going to talk about, well, what if it's not 1? What do you do? Now, the way I'm going to show you today will actually work if a is not 1, or if that number in front is 1 or is not 1. It'll work both ways. So today, if you want to look at one universal way that works all the time, today's the day, all right? So let's start with this. How to factor ax squared plus bx plus c, where a, comma b, comma c are just numbers, right? We also say a is not 0. Why would I say a is not 0 here? What if a was 0? Then this wouldn't be x squared anymore, would it? If a was 0? If that number right there was 0, then everything would be gone. All you'd have was bx plus c. It wouldn't be 3 terms anymore, would it? Did y'all see that? Okay. Okay, so we're going to start with an example. All right. So what I'd like to do, I usually use my calculator to help me generate problems. Makes it a little easier. Let's try 6x squared minus 11x plus 4. Now, last time, let me go back again real quick and show you something. Last time, towards the end, do y'all remember us doing this right here? And a lot of people kind of liked this way. We're going to do something similar to that. So I just want to remind you that that's what we did look at. Okay, so before, what we had done when the number in front of x squared was a 1, all we looked at was the 4 and we looked at the negative 11, right? That's all we looked at. Today, we're going to have to do something slightly different because the number in front of x squared is a 6. So what we do is we take the number 6, and then we take that positive 4 in the back, and we multiply them. All right, so I'm going to multiply them. And now I'm still going to make that big X over here. Remember that big X we did? We use that to kind of help us. What we do is we put whatever we got with this multiplication, we put it in the top of this X. So what is 6 times positive 4? 24. Okay. Then in the bottom of the X, we still just work with that negative 11, the number in front of the X. Okay, so that negative 11 comes from here, and then that 24 comes from what you get when you multiply that through. Okay? That's the only difference, as of right now, that's the only difference in the two methods. You have to take account for that 6. Now, think about it. In the previous class, what was the number that was in front of x squared? It was 1. So we really were doing this, weren't we? Because 1 times 4 would have been 4. And it always would have been 1 in the last class, right? But we didn't really know we were doing that, but that's what we were doing. So it's 6 times 4 is 24. Now, keep in mind that when we have this trinomial, we have already said there's no GCF, right? Like, before I even should have started this, I should have said, do I have a GCF? How many terms are there, right? But we're past that now, okay? So this is, up to this point, there was nothing we could pull out. It was 3 terms. We're trying this method. Okay, now same thing as before. You have to come up with a list of numbers that multiply to be 24 and add up to be negative 11. What can you tell me about the numbers? Because it's positive 24, right? What can you tell me about those two numbers as far as their signs? Well, if they're negative and positive, they would multiply to be negative, wouldn't they? But see, they have to multiply to be positive. So it's either positive and positive, right? Or negative and negative. However, they have to add up to be a negative number. So you can't take two positives and add them and get a negative. The only way you can add two numbers and get a negative is if they're both negative. So by looking at just these two, because that's positive and because this is negative, I know that my two numbers should be negative numbers. Do you all understand the logic behind that? Now let me just make a table of all the ways that I can get 24. 1 and 24, 2 and 12, 3 and 8, right? 4 and 6. Anything else? No. Now, of all these numbers, is there any way to get an 11 out of these? The 3 and the 8, right? The 3 and the 8 add up to be 11. But I need it to be negative 11, and I know that both of them have to be negative. So how about a negative 3 and a negative 8? So let's put those numbers up here, negative 3, negative 8. So far, again, other than that little multiplication in the front that we did in the very first step, other than that, this is identical to what we did last class, right? Now, what we were supposed to do is once we found those numbers, don't write this down yet, okay? What we did last class is we just did parentheses, right? We put x, don't write this down, minus 3, minus 8, right? And we were done, weren't we? This is not going to work this time because, look, if I multiply this out, if I think that's the answer and I FOIL this, x times x is x squared, right? What are we supposed to have? 6x squared. 6, right? So, look, there's all different ways. I've told you this last class. There's all these different ways of teaching this topic. This is the way I like to teach it if I'm allowed to. So here's what we're going to do instead. We're still going to do a set of parentheses, all right? We're still going to put the minus 3. We're still going to put the minus 8. So far everything's good, right? We are also going to put an x in front of these, but leave a space in front of the x. Okay, notice how I left a space in front of both of these? Yes? Okay. Next step. What you have to do now is you have to look at the number that was in front of x squared, which for us is a what? 6. What you're going to do is you're going to take this 6 and you are going to put it in front of this x and underneath this 8. Hold on. In front of this x and then underneath this 8. Okay, do y'all see that? Or, hold on, or you could have done it the other way around. You could have also done it where the 6 goes in front of this x and underneath the 3. But no matter what, you have to put the 6 in front of one of the x's and then underneath the number in the other parentheses. Okay, what was your question? It will sometimes turn into a fraction, like in this particular case. All right? This is a big step, though. If you forget this, it's wrong, right? So let me do it. I'm going to do it the first way, okay? You understand that you have a choice? Let me do it the first way. I'll write it down, and then we'll do it the second way, and I'll show you that they both give you the same answer. All right? Okay, so going the first way, if I do that first one, it would become what? 6x, right? Minus 3, and then x minus what? 8 over 6. Now, it appears to be like maybe we're done, but there's a little more work that we can do. Like this fraction can reduce, right? That fraction 8 over 6 is the same as what? 4 over 3. Agreed? Also, look at the first parentheses here. Is there a GCF? There's a 3, right, that I could pull out? If I pull out a 3, it becomes a 2x minus 1. Do y'all agree? Now, this is completely factored, all right? Here's where things are going to get tricky. When you factor things, they don't always have to look the same, and you can still have the correct answer. So if you check in the back of the book might have something different than this. The only way to truly check your answer is to multiply and FOIL this out, all right, which I'll do in a second. But let's just box that as the answer for now. Now, let's do it the other way. Had I done it the other way, the 6 would have gone in front of the x on the second factor, and the 6 would have gone underneath the 3, right? Let me try that. I would have x minus 3 over 6. Then I would have 6x minus 8. Do you all agree with that? You see the difference? Now, the only thing that left to do here is I have a 3 divided by 6, which is the same as 1/2, right? 3 goes into 3 one time, 3 goes into 6 twice. What about that second parentheses? Do I have a GCF there? I can pull a 2 out of this one, right? So pull a 2 out. I'm going to put the 2 in the very front. Well, I didn't pull the 2 out. You see these two answers? They don't look the same, do they? They look different, don't they? But if you multiply them together, you will get the same result, which should be the original problem. All right, now, should we go through the exercise of multiplying these out? We can, just to check it. Okay, let's do the second one first. Let me do this first. How about multiplying that 2 through? Remember that 2 came out of this one, the second factor? Let's multiply that 2 through. Why do you think I want to multiply that 2 through the first one? Right here. What's going to happen when the 2 hits the half? It's going to become a nice number, right? So multiply that through. So I'm checking right now. That's supposed to say check. I'm checking. I get 2x minus 1 times 3x minus 4. And now do FOIL. What's 2x times 3x? 6x squared. What's 2x times negative 4? Negative 8x. What's negative 1 times 3x? Negative 3x. And then what's negative 1 times negative 4? Positive 4. And if I collect like terms together here, what's negative 8x, negative 3x? Negative 11x. So I have 6x squared minus 11x plus 4. And if you check back up at the top, that's the original problem. So that worked. Understand? Okay, now let's just show that this one's the same too. Remember we pulled that 3 out? Wouldn't it be nice if that 3 was in this one? Because wouldn't it wipe out that fraction also? So I'm going to pass the 3 just through this parentheses, which would leave me with 2x minus 1. Multiplying the 3 through here and here, what would I get? 3x minus, what happens when you multiply 3 times 4/3? The 3's cancel, right? And you just get a 4. 3 times 4/3, the 3's would cancel. Or you could say 12 over 3, which is 4. So you get 3x minus 4, don't you? Well, wait a minute. Isn't that this right here? And don't we already know that turns into this? So these are the same. So it gives you the same result. Now, I'm not going to go through and explain why this works, okay? That's the one drawback to this method, is that I don't get to explain why the 6 in front and 6 underneath will always work. If you're interested in knowing why it will work, I actually have to show you a complete kind of proof of it, and I'll be happy to sit down in my office and show it to you if that's what you want to see. But for this class, we're just going to take it on faith, all right? Okay, let's try another one. How about this? 5x squared minus 26x plus 5. Now, I'll be a little more methodical here. Do we have a GCF? No. How many terms? 3. Okay, so we try this method. The method I'm doing today will always work, right? On 3, well, will work no matter what's in front of x squared. So let me make my little x over here. And then what number is going to go on the top of that x? 25. So I'm going to multiply the 5 times the 5. That gives me 25. What number goes on the bottom? Negative 26. Right now, what can you tell me about the numbers that I'm trying to find? They're both negative, right? Because they have to multiply to be positive, but add up to be negative. The only way two numbers are positive is if they're both positive or both negative. The only way they add up to be negative is if they're negative, right? So I know that it's two negative numbers. Now let me try some numbers here. The factors of 25, 1 and 25, and 5 and 5, right? That's it? Any of these add up to be 26? 1 and 25, but I just need to get their signs correct, right? So negative and negative. Negative 1, take away 25, you get negative 26. Everyone agree that that table works? Okay, so now what I'm going to do is I'm going to put what here? Well, I always recommend that you wait on the 5, okay? First, fill out the rest of it and then decide where you want to put the 5. So I'm going to do two sets of parentheses. I'm going to leave a space, put X, and then I'm going to put what? -1, and then a space, and then X and minus 25, okay? Now you get to choose now whether or not you want the 5 to go in front of the first X or the second X. And then wherever you put it, the 5 now needs to go underneath the other one's number, right? Which one makes more sense to do? Put the 5 in front of the first one and underneath this one? Why does that make sense? That's right. 25, when we divide it by 5, will be 5, won't it? But if we did it the other way and put the 5 in front of the X and the 5 under here, we'll have a fraction. So both ways would be correct, but one way looks better. You know what I'm saying? It's easier to work with because it doesn't have fractions in it. So I'm going to take that 5, I'm going to place it in front of this X, I'm going to place it underneath that 5, or underneath the 25. Then I'm going to say 5X minus 1 times X minus what? 5. That should be the answer right there. Notice there's no GCFs in these, right? There's no GCF in the first two. There's no GCF in the second two, so I can't pull a number out like I did in the last problem. And we can always check it, right, by multiplying it. So I'm going to do a quick mental multiplication. What's 5x times x? 5x squared. So I'm feeling good, right? We've got 5x squared. What's 5x times negative 5? Negative 25x, right? What's negative 1 times x? Negative x. So I had a negative 25x and now a negative x, and I put them together. That should give me a negative 26x. Then I have negative 1 and negative 5, and that gives me positive 5. So it works. All right? Questions, comments, concerns, gripes? There are different versions of what the final answer could be. If you left it like this, I mean, I do want you to reduce the fractions, but if you left it like this, I would have been okay. This would have been okay. Well, hold on. This one would not be okay because it's not completely factored. That had a GCF in it. You pull that 2 out, this would have been okay. If you decided to multiply that 2 through and get this, this would have been okay. All right. It just... That's right. I will be able to see it and know if it's, you know, when you get to a point that, the point that you stop is when each of these things is factored. Like there's no here you wouldn't be there because that has a GCF. Now I would give you a lot of credit for it, but it wouldn't be full credit. If that's what I was saying, the trouble with this section is that when you go and do the homework and check your answer in the back of the book, your answer may not look like theirs. Because look at this answer. Look at this answer. They're different, right? And then look at this answer. This is still the same, but it looks completely different than this. So what you're going to have to be able to do, if you really want to check your work, is multiply your answer out. If it comes out to be the original problem, you've done it correctly. Don't worry so much about what the back of the book says. All right, that's important here because I don't want you going crazy. I can't get the answer in the back of the book and get all pissed off. You know what I'm saying? Okay, did I address your question? Okay. All right, let's do another one. negative 16x squared minus 36x plus 10. All right, what do we do? Okay, good. We have a negative, don't we? Now, we said last class when we have negatives in front of the x squared that we prefer to get that out of there. And same with this method. This method will work even if you forget the negative, but it's just easier to work without the negative in front here. But there's also something else. GCF. What's our GCF? A 2, right? So we're going to factor a negative 2 out of this entire thing. Right? Every one of these is an even number. They're all divisible by 2. So I'm pulling negative 2 out. What will I have left? It'll be positive because I pulled the negative out, right? Okay. Then plus or minus? Plus careful. 18. It's all right. 18. What's half of 30? 15, right? And then you need 6 more than that, right? And you're dividing by 2, so you need 3 2s to get 6. It all depends on how your brain's wired, how you look at division, right? It's 18, all right? 18x, and then minus 5, right? You have to be careful with that negative you pulled out, right? By pulling a negative, it changes the signs of everything that you had, right? And then you're basically taking half of each number. All right, now let's look at what's in here and try and figure out how to use that x to make this happen. So what am I going to multiply so that I can get that number in the top here? 8 and negative 5. You have to take account for the sign of that number. What's 8? Positive 8 times negative 5. Negative 40. Right? Negative 40. What's the number on the bottom? Positive 18. All right, so let's think about this. What's the only way that I can multiply two numbers and get a negative? One of them is positive and one of them is negative, right? They have to be opposite in signs. So one's positive, one's negative. And then when you add them together, it has to be what? Positive. That means the positive number I have is bigger than the negative number, because when I add them, I should still get a positive number. But the main thing is the negative 40 tells us these two numbers should be different signs, right? One positive, one negative. Now let's come up with a table of all the factors of 40. So 1 and 40, 2 and 20, 3 doesn't go, right? 4 and 10, 5, 5 and 8, 6, 7, no, 8, we already have it, right? Remember, you stop once you get to a point where you have a number you've already used. Do any of these come together to become an 18? 2 and 20, right? Now they add up to be 22, but if you subtract, you get 18, don't you? So I need to make which one of these the negative? The 2 needs to be the negative. Now up here, look at my cross. I could put minus 2 and 20 like that, right? Or another person sitting there could have done it the other way around and put 20 into minus 2, right? It doesn't matter. It does not matter which one you put where. And that's because, remember, in the two parentheses, we can always switch them, right? The two parentheses. So that's the good news. You can't go wrong here with the order in which you put those two numbers. Now I'm going to be real careful with this. The negative 2 we had in the very beginning of the problem, right? Negative 2. Then I'm going to write two sets of parentheses, little space in front of my x, a space in front of my x, plus 20, minus 2, right? Am I done? Nope. What do I need to look at? The 8. That 8 needs to get dropped down in front of the x and underneath this 2, or in front of this x and in front of underneath the 20. Neither one of those will become a nice number, right? Like the last problem is 25 over 5. We're going to have fractions no matter what, aren't we? So there's not one that's necessarily better than. So I don't care. Where do you want to go? Where do you want the 8? You want under the 2? And in front, that means it has to go in front of the other x, right? Okay. If I do that, I get 8x plus 20. And then over here I get x minus what? 1/4. That. Am I done? No, because unfortunately, by doing it that way, I created a GCF in the second factor. So what number can come out of both 8 and 20? 4. 4, right? So pull a 4 out. That negative 2 will multiply times what you pull out. So what's negative 2 times 4? Negative 8. When you pulled the 4 out, it left a 2x plus 5, didn't it? And then you have x minus 1/4. You could box that, and that would be correct. Did anybody try and do it the other way? Putting the 8 in front of the other one? You want me to show what you get with that, or? Okay. So let's say we had done it the other way, which would have looked like this. We would have had negative 2, x plus 20. Did you do it x plus 20 like that? But you just did the 8's opposite? Okay. So if you put the 8 instead in front of the x here, and then underneath the 20, then you get negative 2, x plus, let's see, what goes into both 20 and 8? 4, so you get 5 over 2, and then over here you get 8x minus 2, but we still have a GCF there, don't we? What can we pull out of this one? 2, so that 2 comes out and multiplies there, comes negative 4, x plus 5 halves, and then we pull the 2 out, 4x minus 1. Bless you. Now, let me just tell you a little something here. If you go to the tutoring lab and show them this is what you're doing, the tutor might try and force you to do another method because, like I've said, there's so many different methods out there. Just be aware of that. You might get frustrated if you get help on this, all right? Well, I don't know. It'll depend on the tutor. And there's just so many different variations of this. But here's the reason why I show this. Because you might go sit with the tutor, and the tutor might show you something. You're like, you know what, that's easier or something. You may think that. But I guarantee you, this method right here that I've shown you will work all the time, even if you forget to pull a GCF. Okay? Even if you forget the GCF in the very beginning of the problem. Look at this. Let me go back up here. Way up here. If I were to take this right here, okay, if I were to take that problem again and I just forgot the GCF, completely forgot, all right, then I would do negative 16 times 10, which would give me negative 160, and then I'd have negative 36. Now my numbers suck because they're big, right? But let me see if I can get this. How about, well, that might take a little while to figure this one out. 160. So what? 1 and 160? That's not it. 2 and 80. 3? No. 4 goes in there 40 times. Ah, wait a minute. Hold on. There we go. 4 and 40. 40 minus 4 is 36. So if I go 40 here and minus 4, right? That'll work? Agreed? No? Oh, I have it backwards. Yes, that's right. Thank you. I'm glad you. Negative 40 and 4. My apologies, right? We have to have a negative here? Okay. So now, watch. Two sets of parentheses, right? Negative 40, positive 4. Yes? Yeah? What's the number in front of x squared? Not 16. Negative 16, right? So I get to put that wherever I want. So how about I do this? How about I put the negative 16 under here, and then negative 16 in front of the other x? Y'all see how I did that? Okay, now this reduces. What goes into both 40 and 16? 8. 8 goes into 40 how many times? 5. 8 goes into this? 2. Now, a negative divided by a negative should be a what? Positive. So you get x plus, we said 5 over 2. And then over here, negative 16x plus 4. And what can I pull out as a GCF here? 4 or negative 4. It doesn't matter, right? I'm going to pull a negative 4 out. And I'd be left with the 4x minus 1, right? Now, does that match anything we had before? Is it this one? It doesn't have to match, but I'm wondering if it did. Is it that one? Yeah, it is, right? So it makes me feel good. Now, the reason why I'm showing you this, again, because you may go and sit down with a tutor that may show you a method like this, and they may give you a method where it totally gets rid of this idea of fractions in here, which you may be like real happy about. But that method, I guarantee that you're shown, if you forget the GCF, it's over, okay? It is over. That method will not work. So they always tell you, you have to pull GCF first. You have to pull, which is great. I mean, you have to pull, you're supposed to pull GCF first, right? But what if you forget to pull GCF? I'm showing you this because I want you to have a way that even if you pull a GCF, you know, have you ever pulled like 2 out, but it could have been a 4? Okay? If you do that on a different method, it won't work. You have to pull the entire GCF out. So this to me is just safer, and that's why I show it. All right, let's do one more, and then I want to try and cut you loose on some to let you practice, and then we'll do. Yes.
On that last one, you said that you can pull a negative 4 or a 4, so it doesn't matter.
Where? Oh, in the one right here, the one.
Yeah, sorry.
Yeah, if you would have pulled a positive 4 here, right? This would have been a negative 4x and a plus 1.
Okay, tell me.
It would have still been correct.
Okay.
Yep. That would be personal preference.
Okay.
Yeah.
All right.
Yep. All right. Last example. Negative 7x to the 4th minus 19x to the 3rd plus 6x squared. What's the first thing you consider? GCF. You see anything that they all have in common? An x squared, right? X squared. Now, we also have a negative in front of the 7. Would you like to get rid of the negative? You don't have to, right? You can if you want. I always say if you're going to be pulling something out anyway, may as well pull a negative out with it. So I'm going to factor out a negative x squared. Now, by pulling the negative, it's going to change the signs of everything in there, right? And every power on x is going to come down by 2. So I should have 7x squared, right? then positive 19, x, and then minus just 6. All right. Now what's inside the parentheses is a trinomial, 3 terms. I'm going to try this method, which means I'm going to create my x. I'm going to multiply what and what here? 7 and negative 6, right, to get negative 42. The number on the bottom, 19. I know right now that one of the numbers has to be negative and one has to be positive, right? Let me try and list out all the different ways I can get 42. 1 and 42, 2 and 21. Shall I keep going? You'd say stop, because you see that 2 and 21, if I subtract, I should get a 19. So which one is going to be positive on this? 21, so I'll put 21 there, and I'll put the minus 2 here. Now, coming back to the answer, what comes first here? What do I put first here? Minus the x squared, right? Don't forget that thing we pulled out in the very beginning. Then your 2 sets of parentheses, a space, and then x plus 21, then a space, x minus 2. What's the space for? The 7, right? I have to take into account that 7. What looks best to you here? 21 over the 7, which forces my 7 to go in front of this x. Right? So let's clean this up. Negative x squared, x plus what? 3, right? And then 7x minus 2. Do I have any GCFs left inside of these two factors? No, right? There's nothing I can pull out? What question? What are you saying? No, explain. What x? This? Are you talking way back up here? Like when I pulled this out? If we do this, right? If we do this, we know we're going to get 7x squared, right? And then we come in with this, that'll make it a negative 7x to the 4th, which will take us back up there. Right? So you do that first, then come through and pass that through if you wanted to check it. Yes? That's it. We could box it up. Okay? Now, I said that's the last example. I kind of lied. I just want to show you that this is what we did last time. If we did a problem like this, like from last class, right? The way we did it is we made this little thing and we looked at the negative 4, right? Well, now treat it like we did today. There's a 1 in front, right? Multiply the 1 times negative 4, you still get negative 4. The number that goes on the bottom, negative 3. You play with the numbers, you get negative 4 and positive 1. Then 2 sets of parentheses. We put minus 4, we put plus 1. I put an x and an x. I leave a space in front of them, right? But why does it not matter? Because I'm going to be using a 1, right? What's a 1 in front of x? Still x, right? And then what's either one of those divided by 1 is itself. So we actually did use that method. We just didn't really realize that's what was happening. Which is why when I normally teach factoring, I start with this method that I'm showing you here, with the multiplying cross. And then you never even realize that when you have a 1 there, it's a different case. It's all the same. But I tried to follow what the department wanted me to do this time. So that's it. You're just done right there. Because, right, no matter what I do, 1 here and 1 there, nothing changes. It's still x minus 4 times x plus 1. All right. I'm going to put up some in-class work for you to do. Let me pause. Yes? So the homework or the in-class work is 16 through 22 even. Sorry, I didn't put even there. And so that's 4 problems, right? And then let's do 15 through 39 odd. Your quiz will be these 4 problems, but you're allowed to work together right now and try and get it done, okay?